In this lesson, we are going to cover the basics of Java servlets. Servlet is an important part of Java web application. If you break down a Java web application into data, user interface, and processing, then the processing part is usually implemented using servlets. Besides servlets, there are also some other components in a Java web application, like beans, filters, additional Java libraries in the form of jar files, JSP pages, static resources like HTML page, style sheets, images, and so on, and some metadata files. In this lesson, we'll focus on Java Servlet, and we'll discuss a little bit about the metadata file web.xml. The Servlet specification defines a standard folder structure that all Java web applications must follow. Different components need to be placed under the right folder in order for the application to work. The top-level folder is called the application root, which contains the whole application. JSP and other static resources can be placed directly under this folder or some user-created subfolders. There is a special subfolder called web.info, and the web.xml file is placed under this folder. Also under this folder are two other special folders, classes and lib. Compiled Java classes should be under the classes folder, and the jar files should be put under the lib folder. If you log on to CS3, you can see that the www folder follows exactly this structure. Let's take a quick look. So I'm going to log on to my CS3 account, and let's go under the www folder and let's see. As you can see, under the www folder we have web.info, and under web.info we have classes, and our compiled Java classes are under this folder with a substructure corresponding to their package names. And under web.info, we have web.xml, and we also have the lib folder under web.info, which is currently empty. And the JSP file is placed directly under the www folder. All in all, as you can see, www is basically the application root folder. And you can have web.info, classes, libs, and so on underneath it, and all your class files, JSP pages, and static resources in their rightful folders. The folder structure used by Eclipse is slightly different from the standard. Let's create a Java web application in Eclipse and see how it looks like. So let's pick new and dynamic web project, and I'm going to name my project CS320. So I already have the target runtime selected. 3.0 is the right version, and then next, and then next. Okay, here notice that there's this option called generate web.xml deployment descriptor, and currently it's unchecked. You need to check this. We'll discuss web.xml a little bit more later on. For strictly speaking, for our web application, this file is not required, but there are quite some benefits of having this file regardless. In particular, when you deploy your application onto CS3, the Tomcat server on CS3 will monitor your web.xml file, and if the timestamp of that file changes, the Tomcat server will reload your project to reflect the updated code that you put on the server. Without this file, you may run into the problem that you uploaded some updated class files, but somehow the server is still showing the old version. So it's quite important that you have this file in your project, and if for nothing else, to use this file to force the Tomcat server on CS3 to reload your project. Okay, now we have our project, and we know that under Eclipse, all the projects are stored under the web space folder. So let's go to the web space folder and find our project there. And here it is. As you can see, the first thing we notice is that there's a source folder here for storing Java source code. And this folder doesn't exist in the standard folder structure. This is because the standard folder structure is for deploying a compiled Java web application to an application server. So it doesn't really care where the source code is, since the source code is usually not deployed onto the server anyway. There are also a couple of other differences. In Eclipse, JSP and other static resources are placed under the web content folder here, and inside Eclipse is here. And the class files, on the other hand, are placed under the classes folder under the build folder. So all in all, we can say that roughly speaking, the web content folder in Eclipse corresponds to the application root directory in the standard folder structure, except that the class files are stored in a separate folder under build/classes. It's important that you understand the directory structure so you can find your files in an Eclipse project and later on copy them to the right folders on CS3. So now that we understand the folder structure, let's create a simple servlet and see how it works. So let's right-click on the project, then select New, and then select Servlet. And for each servlet, you should place it in a Java package. And I'm going to create a package called CS320 Servlet, and my servlet class name will be HelloWorld. And next, nothing here. Next, on this screen, you have the option to choose which methods you want to inherit from the HTTP Servlet superclass. And here we'll select doGet. As you can see, there are quite a few methods that you can choose. Most of those methods have the name do something, like do get, do post, do put, do delete, and so on. So we'll talk about where those names comes from in the next lesson when we discuss different HTTP request methods. For now, let's just pick do get and be done with it. So once we click finish, Eclipse will create a skeleton servlet for us, and let's get rid of the generated comments so it's easier to read the notes, read the code. And this servlet currently doesn't do anything, and let's create some output. We'll say response.getWriter print and hello world. And hopefully this will print out the sentence hello world. And let's run this code, and we can either run the whole project, run the right click on the project and then run on server, or let's just run this servlet, run on server. When we first run the project, it will ask us to pick a server runtime. So we'll pick the Tomcat 7 that we set up before, and we check always use this server to run this project, and it will deploy our project onto the server. So click finish, and voila. So hello world it is. Now, although this is a very simple example, there are actually quite a few things we need to discuss. So let's first refresh our memory about web application. Remember that a web application is simply a program that runs on the server. When an HTTP request comes in, the application server will pass a request to the program as its input, and the program will produce a HTTP response as its output. Now this picture is what I call the big picture of web application. And if you keep this big picture in mind, it's quite easy to understand what's going on in our servlet. As you can see here, this servlet is really just a very simple web application. Because it's run by an application server, not by a user, there is no main method here like in a regular Java application. Instead, there's a method called doGet, which is called whenever the server receives a request. The server passes the request to the doGet method as a parameter, and the doGet method will process the request, then populate the response with some content, and this response then will be delivered back to the browser by the application server. The servlet class needs to inherit from a superclass called HTTP Servlet, and this superclass contains code that takes care of the interaction between the servlet and the application server, or this part, so that our class or our code can focus on implementing the application logic rather than dealing with the interaction with the application server. In the next lesson, we'll take a much closer look at HTTP request, and we'll see why the method is called doGet and how to utilize the request parameter. For now, let's just focus on the response part. We'll change the code a little bit so it generates a HTML page instead of just plain text, hello world. So how do we generate an HTML page? We know that the HTML is simply text with text, right? So there's really nothing special that we need. All we need to do is just print out the additional text that includes the additional strings that include the HTML text, and then the browser will take care of the rest. So to create an HTML page, we'll need the HTML tag and the head, the body, and so on. So to make the code a little bit better, let's create a variable for the for output. So response get writer will store that in a variable called out. So from out, let's print out the HTML tag, the head tag, and the title, let's call it hello. Just call it hello. And then the body tag. So inside the body tag, let's print hello world, and this time let's put it in a header tag so that it looks more prominent. And then let's close the body tag, and let's close the HTML tag. So this is pretty much a simple HTML page. There's nothing really special we need in order to generate this, just print out those tags. And one more thing we need to do is set the content type of the response. And we'll say response set content type. And for HTML pages, the content type should be text/HTML. And that's more or less it. So we save it, and we wait a little bit. The server should restart automatically. Okay, it did, and then let's refresh. Okay, So this is actually a good example of doing some debugging. I have a few debugging tips at the end of the lesson, but this is, I guess, a good place to bring up one of them. So sometimes we'll change your code and then we'll run it. You'll see a blank page like this. Now, it's possible that your code didn't work at all and didn't produce any output, or it's also possible that you just made a simple mistake, and oftentimes it's writing a wrong HTML tag. And if you have a wrong HTML tag, the browser may not be able to display anything at all. So we'll look at a blank page like this. The first thing you do, instead of trying to find what's wrong with your code, is do a view source. A view source will let you to see the source of the generated HTML page, and oftentimes you can locate the problem right there, and oftentimes it's some problem with the HTML tag. So as you can see, our code did generate some output. We have the HTML tag, we have the head tag, title tag, and the problem is here. I have a typo in the close tag of title, and so that's probably why the whole thing is not displayed. So let's go back and then fix that. And title, head, body, HTML. So let's see. Save, wait a little bit until the server restarts, and refresh. Now it comes up. So this is, again, a very simple example, but there are few things I'd like to point out. Now, the first thing is regarding the output. In regular Java applications, we used to use system.out.print to generate output. And here, instead, it's response.getWriter.print. The reason is pretty simple. Instead of writing output to the console, we are now writing output to the HTTP response, which will be sent back to the browser. They are both output and just output to different places. Second thing I already mentioned, which is that HTML is just text with tags. So to generate HTML, all we need to do is just print out a bunch of strings. There's nothing special that we have to have in order to do that. And last but not least, it's good practice to always set the content type for your response. Although most of the time the response is an HTML page, it sometimes can be something else like an image, a style sheet, a JavaScript file, and so on. Setting the correct content type will help the browser to properly display the response, so the browser doesn't have to guess what the content type is. Now that we know how to generate an HTML page, let's talk about servlet mapping. In a web application, there are usually more than one servlet, and which servlet should be used to handle the request is determined by servlet mapping. Servlet mapping takes a path component of a URL, which is this part, and tries to match it to the URL pattern declared by a servlet, which is here. If a match is found, that servlet is used to handle the request. Before Servlet specification 3.0, the URL patterns must be declared in the metadata file web.xml, but now we can use the web servlet annotation to do it. Speaking of annotations, most of you probably already used it before or at least heard of it. It's a language feature introduced in JDK 1.5. Annotation is not part of the code of a program, but it can be used to provide some information about the program. And since its introduction, it's being used very widely in Java development for various purposes, especially in Java web development. For example, annotations can be used to indicate that a method is overriding a method in the superclass. It can be used to suppress some compiler warnings. It can be used to declare servlet URL patterns, and it can be used by some library to turn some classes and methods into web services. There are a few things I'd like to mention about annotations. First, each annotation may have elements, like the value element for the web servlet annotation. I sometimes call these elements attributes, but their official names are elements, and so don't get confused. The default element is value, and if there's only one element and it's the value element, then the element name can be omitted. So from here, we can simplify the annotation to this one by omitting the value element name. Each element has a type, just like variables in Java. Element types can be some simple types like numbers, strings, arrays, and other annotations. In this example, the annotation is actually a string array. And when there's only one item in an array, the array braces can be omitted, which is why the web servlet annotation looks like this, which comes from the original form, then omitting the default annotation element name, and then omitting the braces for the array. If you look at the documentation of the web servlet annotation, you can see that there are quite a few elements, but all of them are optional. You don't need to worry most of these elements except value, URL patterns, and lowdown startup. Lowdown startup determines whether a servlet should be started when the application is deployed. And we'll talk about lowdown startup a little bit more later. As for value and URL patterns, both of them actually serve the same purpose, which is to declare the URL patterns that a servlet handles. One of these elements must be specified for the annotation, and the convention is that use value if you only need to specify servlet mapping, and use URL patterns if you need to specify other elements as well. Let's take a look at a few servlet annotation examples. So we already saw this example, which is what we have here. And we know that by doing this, this servlet declares that it should be the servlet that handles the URL HelloWorld. And this is why when the user sends a request to this URL /HelloWorld, and that request is handled by this servlet. If, for example, we try a different URL, obviously there's no servlet that handles that URL at this moment. The nice thing about servlet mapping is that unlike using static files, which each static file must correspond to one URL, we can map multiple URLs to the same servlet. For example, let's say that we also let this URL to handle let this servlet to handle two additional URLs, A and B. And because now we have 3 items in our array, we now have to use the array braces. So save, wait a little bit for the server to restart. And let's try this again. So now this URL A maps to this servlet as well. So does B, and the C is not. Another thing we can do is to map a wildcard pattern to this servlet. For example, we can say that let this servlet to handle everything that starts with /member/ and let's try that one. So let's do /member/star. Save. And if you don't want to wait, just restart. Okay, it's restarted. And A still works, B still works, C doesn't work. How about member C? Member C works, right? In fact, the member anything would work, because every URL that starts with /member/ would be mapped to this URL. And we have a couple of additional examples here, which shows you how to use some other elements of the web servlet annotation, like the name element and the init prime element. Notice that when you have more than one element specified for the annotation, the convention is that you use URL patterns to specify the URL patterns instead of the value element. Now, when it comes to URL patterns, you need to be very careful, because it's very easy to end up with some invalid patterns. The most common error is to forget the leading slash in the URL, like this one. Remember that all URL patterns must start with a slash, except there's one special case which involves a wildcard pattern. Now, as for wildcard patterns, it's also quite easy to end up with a invalid wildcard pattern. For example, this one, /member/star.html. Now, if you look at this pattern, it looks quite reasonable, meaning meaning is quite obvious, right? We want to handle all the HTML pages under a certain directory like member. However, this URL pattern is actually invalid. When it comes to wildcard URL patterns, the Java servlet specification only allows two types of wildcard URL patterns. It's either a string begins with a slash and ends with a /star, like /star or /content/star, or what we had here, /member/star. Or it has to be a string that begins with a star dot, like a star.html, star.do, and so on. And this URL pattern is the only URL pattern that does not require a leading slash. And based on that, as you can see, this /member/star.html does not meet either requirement. So it's an invalid pattern. And if you have an invalid URL pattern, you'll end up an error when you try to start the application. And sometimes the error message is not that obvious or clear. So be careful with your URL patterns. And don't forget the leading slash, and we'll create a wildcard URL pattern. Make sure that it satisfies one of these requirements. Sometimes you may also end up with conflicting URL patterns. For example, two servlets map to the same URL. And this happened actually quite often. And in previous quarters, lots of students would create a servlet and then copy that servlet and modify the code to produce another servlet. We'll do that. Remember to change the URL pattern, not just changing the code. Otherwise, you would have two servlets mapped to the same URL pattern. And again, when you try to start your project, it won't start. Last, there's sometimes you would end up having overlapping URL patterns. For example, you may have a servlet that is mapped to the star.html and another one mapped to /member/star. And what happens if you have a URL like /member/a.html? Which servlet is supposed to handle this request? It's not quite clear. In this case, you actually won't get an error because the application server follows certain order to match URL patterns, and the application server will return the first servlet that matches this URL. However, that servlet may not be the servlet that you have in mind, so it's better to avoid using overlap patterns, and in particular, URL patterns that have wildcard symbol in it. Okay, now that we know the basics of servlet and we've got as much as we can from the HelloWorld example, let's do another example. In this example, we are going to create a request counter. When you visit some websites, sometimes you'll see a counter on the website that says you are visitor number 1000 or 1001 or something. Let's see how we can implement that. So before we create a new servlet, let me stop my server. And let's create a new servlet. I'm going to call it request counter. Now in this servlet, we are going to inherit the doGet. We are going to override the doGet method as well as the init method. We are going to use the init method to initialize the request counter value. Again, get rid of the generated comments first. And to create a request counter, just like in regular Java code, we have to have some variable to hold the counter value. And let's create a variable inside the request counter class, and I'm going to call it counter. Now inside the init method, I'm going to initialize the counter value to 0. Because the init method is actually overriding a superclass method, here we would also want to call the superclass init. And this is actually very important, and it's something that easy to forget. Without calling this superclass init method, the servlet context object will not be initialized properly, so you'll end up with lots of problems later on. When you override the init method, always remember to call the superclass init method first, and then do whatever you need to do later. Now as for the doGet method, I'm going to recycle some code from HelloWorld. And for the display part, we'll say this is the request counter servlet, and we'll say you are visitor number and whatever current counter value is. And if we don't do anything, the counter value is of course always 0. So let's increment that counter here, and this should do it. So let's run request counter. It shows we are visitor number 1 because we incremented the counter before we do the display, so it starts with 1 instead of 0. If we refresh this page, it becomes 2, refresh again, 3, again 4. So notice that each time when we refresh, we get to this doGet method, and doGet method increment the counter, and that's why we are seeing the counter keeps incrementing. For this example, the important thing is the servlets, the so-called servlet lifecycle methods. We've seen 2 lifecycle methods in our example, init and doGet. So the init method is only called once when a servlet is started. So this is a good place to do some initialization, like setting the counter to 0. Whenever a request comes in, a service method is invoked, and based on the request type, which we'll discuss in the next lesson, the request is dispatched to one of the do something methods like do get, do post, and so on. And in this case, it's do get. And this is why each time we refresh the page, the counter is incremented, because each refresh of the page sends a new request to the servlet, and that request is dispatched to do get, and then this do get is invoked to increment the counter and create the response. There's also a destroy method which we didn't use in our example. This method is called when the servlet is destroyed, and this is a good place to do some cleanup work, like releasing some resources held by the servlet. Note that a servlet is only destroyed when the server stops or when the application is uninstalled from the server. You might be wondering why we initialize the counter in the init method instead of in the constructor, like in here. I have a short write-up on this topic on the CSNS wiki that you can take a look. The short answer is that initialization inside the constructor has some limitations. In particular, you cannot access servlet context inside the constructor. As we'll see in the next example, being able to access servlet context is actually quite important. A Java web application usually consists of more than one servlet, and a common problem is to share data among multiple servlets. Let's say that we want to change our request counter example so that we use one servlet to increment the counter and another servlet to display the counter. So the question now is, how do we share the counter between two servlets? Based on the knowledge of regular Java applications, you may be thinking that we can define a counter as a variable in one servlet, as we did here, and in another servlet, just keep a reference to this servlet and then use that to access this counter variable. Unfortunately, this won't work in a web application because two servlets, by and large, can be considered as two separate programs as opposed to two classes in the same program. You can't really simply access a variable in another servlet from one servlet. The solution here is to use something called application scope. You can think of application scope as a storage area where data can be stored and accessed. Data in application scope will remain there as long as the application is running, and data in application scope is shared by all servlets. You can access application scope through the servlet context object. In particular, there are two methods in the servlet context class: set attribute and get attribute. You can use set attribute to save an object in the application scope, and you can get the object by its name using get attribute. Let's see how it works in our example. And again, let's stop the server first. And since now the counter has to be shared between two servlets, we can no longer use that as a variable inside this servlet. So let's get rid of that. And what we would do is we would create a counter object and then save it in the application scope, and then so that both servlets can access it. So still inside our init, we'll create a counter, and then we'll store it in the application scope. And to store it in the application scope, we first retrieve the servlet context and then use set attribute. So we do get servlet context and then set attribute. And it doesn't really matter what name we give give to the counter as long as it's a unique name. So I'm just going to call it counter and then the counter value. Get servlet and counter. Okay, so inside the do-get, remember that the example we're going to do is using two servlets to handle the counter, and one servlet to count the number of requests and the other one to display the count. So in order to count the number of the requests, we need to do a few things. First thing is we need to get the counter, and then we need to increment the counter, and then we should give it some display. So we'll say display the message the counter is incremented. Incremented. Yes. So that's the easiest part, and this one will say the counter is incremented. Close the paragraph, and that's about it. To get the counter, we'll have to use get attribute. So let's get the attribute, and the attribute is going to be counter, and we say get servlet context, get attribute counter. So if you do this, notice that there's an error here, and the error says type mismatch cannot convert from object to integer. The reason being that when you save an object inside the application scope, it saves as the object. The good thing about this is that you can save any object into application scope. However, when you get the attribute back, it's also getting it back as an object, and you have to cast it to whatever actual class type that value is. And here we'll have to cast this one to integer in order to get the value back. So once we get the value back, we can increment it, and we need to save it back to the application scope so that another servlet can access the updated value. And to do that, let's do set attribute again. So this should do it. Or if we want to have a nicer looking code, we can do servlet context is get servlet context, and then servlet context get attribute, servlet context set attribute. Okay, so this should do it. And this is the first servlet that increments the counter, and then let's do another servlet that displays the counter. So we're going to call that servlet display counter. And for this servlet, we only need the do-get. Remove the comments. And notice that by default, the URL pattern generated for this servlet is display counter, which is the same as the servlet class name, and that's fine for us. Now, in order to display the counter value, we'll need to do pretty much the same thing as before. We'll have to get the counter first, and that is this part. And we don't want to increment the counter. We don't need to set the counter back. We do need to do display, and the display would be display counter, and then we can say the counter value is currently whatever the counter value is, and this should be it. Yes. So let's try this. We'll run request counter. It shows the counter is incremented. It doesn't show the counter value. Let's click refresh a few times. 1, 2, 3, 4, 5. So now the counter value should be 6. Let's see if it is indeed 6. And let's go to the display counter servlet display counter. And it shows the value is indeed 6. So this is a simple example, but it's a pretty important example in the sense that it shows how to share data amongst multiple servlets. And later on, we'll do your homework up to the midterm. Every homework up to the midterm would require you to save some data in application scope. So make sure you know how to use application scope. It's pretty simple. Just get the servlet context, get attributes, set attributes, and that's more or less it. Now, our example here so far seems to work fine, but there's actually a fairly subtle bug in it. Let's stop the server now. And let's try running it again. But this time, instead of running request counter and then display counter, let's try run the display counter first. So as you can see, instead of a counter value of 0 or 1, we actually see a counter value of null. Now, this is because by default, a servlet is not created until it's accessed for the first time. And this could cause problem if one servlet must be run before another servlet. In our case, the initialization of the counter is done in the request counter servlet. But after we deploy our application, if a user accesses display counter first, instead of 0 or 1, the user will see a value of null, and that's obviously not ideal. There's actually an easy solution for this. We can use an element of the web servlet annotation called load on startup. This load on startup informs the application server that a servlet should be created immediately after the application is deployed. In other words, before any user accesses that servlet should be already created. And to use load on startup is pretty simple. We can just specify an additional attribute for the web servlet annotation. And let's do that. Let me again stop the server first, and then we'll put load startup equals to 1 here. So notice that now we have 2 elements specified for the annotation, so we can no longer omit the element name for the first one. The first one could be either value or URL patterns. And by convention, when we have multiple elements specified for this annotation, we use URL patterns. Now we have that, and let's try again. So the server is currently stopped. Let's run display counter again. Now, as you can see, the counter value is 0, which is the correct value. And the reason being that with load on startup, request counter servlet is automatically started after the application is deployed, so the counter value is properly initialized and the other servlet can display it correctly. Regarding the load on startup, regarding the value for the load on startup element, it's the order in which the application server will start the servlets. If you have multiple servlets that you want to load on startup, for example, you would have 1 for one servlet, 2 for the second servlet, and so on and so forth. You do need to make sure that the load on startup values are different. If you have, for example, 2 servlets both have load on startup equals to 1, that it will create a problem. And again, like the problem of having conflicting URL patterns is actually happened quite often in previous quarters when the students just use a sample servlet to create other servlets and forgot to change the load on startup value. Now let's talk a little bit about the web.xml file. Its official name is Web Application Deployment Descriptor, and it's used to be the most important metadata file in a Java web application. However, since the Servlet 3.0 specification, most of the things that used to be specified in web.xml, like servlet mapping, can now be done with the web servlet annotation. So web.xml is much less important now. In fact, it's no longer even required. However, there are still a couple of things in web.xml that you should know about. If you look at the web.xml file generated by Eclipse, you can see that it's just a regular XML file, like most of the metadata files in Java web development. The web app element has a few attributes, and the ID attributes is the ID of your application. You can name it anything you want as long as it's somewhat unique. And the more important attribute is this version attribute, which tells the application server which servlet specification your application follows. And in turn, it determines what Tomcat and JDK version that you need to use in order to run this application. The web app version and the Tomcat version and JDK version correspondence is listed in this table. So for web app version 3.0, it means this web application is using the Servlet 3.0 specification, which comes with the JSP 2.2 specification, which requires Tomcat 7 and JDK 1.6 or above. And similarly, for other earlier Servlet versions, you would have the corresponding Tomcat versions and corresponding JDK versions. In this class, we always use version 3.0, but sometimes if you look at some other web applications, be careful when you see an application that uses an earlier version. Although the code may be the same, but some default behaviors are different in different versions. Another useful thing in web.xml is the welcome file list, this one. The application server will look for these files if a request URL matches a directory. It's a good idea to have at least one welcome file serving as the front page of your project. For example, let's create a welcome file for our project. Or actually, let's see what happens when we don't have a welcome file. Now, when we don't have a welcome file and we'll try to run the project, let's right-click on the project and then select Run As and Run on Server. And you'll see a 404 page. And the reason is very simple. There's no servlet that maps to the root path of this web application. You do have things like HelloWorld, but then your user would have to manually enter the URL, which is not exactly ideal. So what we can do is we can create a welcome file, and let's do that. A welcome file can be lots of things. It could be a simple HTML page, or it could be a JSP page. It could be called index or default and so on. So it doesn't really matter which one you choose as long as you choose one. So let's choose the simplest one, which is index.html, a simple HTML page. I'm going to create an HTML page, and remember the standard directory structure says that static resources like HTML pages should be under web content. So let's do right-click on web content, new HTML file, and we'll call it index.html because that's the name of the welcome file the server will look for. We will create a HTML file. Eclipse would ask you to select one of the templates, and there are several templates for HTML file, and 4.01 strict or transactional or 5, and I usually would use the transitional one so that it uses XHTML syntax but not strict. And this one, let's call it CA320 examples. And here we can create some links to link to our examples. For example, let's create a list, and we'll have a hello world example here, and we'll have a request counter example, and hello world example is at create a link, and is at hello world. And the request counter is at request counter. And let's run the project again. Okay, so now as you can see, we have a front page for our application, and if I click on this link, it goes to Hello World. Click on this link, it goes to request counter, and that's quite nice. And so you don't have to have a welcome file, but it's good to have at least one for your whole application. Now, last but not least, some debugging tips. By and large, writing Java web applications in this class is not difficult. The applications we are going to develop usually don't involve very complex algorithms. The code is typically pretty straightforward, but since it's something that most of you have never done before, you probably will make lots of mistakes and end up spending lots of time doing debugging. The first and the most important thing about debugging is to read the error message carefully. Most of the time, the error messages is pretty clear about what went wrong. So before you do anything else, make sure you read and understand the error message. Another simple and useful thing is to check the source of the generated HTML. And we have, in fact, demonstrated that when I created my Hello World example, where we saw nothing in the output. And it's not really because the code didn't do anything. It's because simply that I had a typo in one of the tags. And that would happen surprisingly often when you write HTML, when you write servlet code. So a good tip is to check the source of generated HTML if the output is not what you expect. You can either do something as simple as do a view source in your browser, or if your page is very complex and it's hard to eyeball it, you can use some online validator or some browser plugin to help you to check the syntax of the generated HTML. And last tip is to use the Eclipse debugger. If you have a very hard to debug logical error in your code, it's good to use the Eclipse debugger to step through the code and see what are the values of your variables at each step. It's pretty simple to do. And let's say that, let me stop the server first. And let's say that for some reason our request counter code is not, request display code is not working properly, and maybe the counter is incremented correctly, but it's not displayed correctly. So what we can do is we can first create a so-called breakpoint in our code. And to create a breakpoint, just double click on a line. Let's say we create a breakpoint here. You can see that's a breakpoint. What a breakpoint does is when the server runs the application, it will stop at that line. And it will let you see all the variable values at that point, and it also let you to step through the rest of the code one line at a time if you prefer. So let's say that we create a breakpoint here, and then let's debug the project. But this time, instead of select run on server, we want to select debug on server. So far, it looks exactly the same as before. Let's go to request counter. Let's refresh a few times to increment the counter, and then let's go to display counter. So we go to display counter. So when we try to go to display counter, notice that the Eclipse will pop up a window and say this kind of launch is configured to open the debug perspective when it's suspended, and so on and so forth. Simply click yes. And you can see that the execution of the application actually stops here at our breakpoint. And well, the variable counter should be shown here in this variables window. For some reason, it's not showing. Let's try to do a step. Okay, now it comes. And let's customize the perspective so that the debug values, the debug buttons are shown here. Okay, here. Right. The nice thing about using the Eclipse debugger is that first, in the variables window, you can see all the variables inside your method. You can see the request, you can see the response, you can see the counter, which here is an integer of 6. And the second thing is that it lets you to execute the remainder of your code one line at a time if you want. And so that each time you can execute one line and see the changes in the variables and the values. Now, there are two operations when you try to execute the code one line at a time. One is called step over, and one is called step into. The difference between step over and step into is that step over will execute one line of code at a time, and step into will actually step into the a method that's being executed. For example, if you try to do a step into on this line, and instead of executing the next line out.print line, it will actually step into the set content type method and then execute a line inside the set content type method. Most of the time, you probably don't want to do step into because methods like set content type are not your own code, it's the library code. So most of the time, you probably want to do step over unless you are calling a method that's written by yourself and you want to execute a line inside that method. So you can do step over again, and so on and so forth. Now in our simple example, the values of these variables don't really change, so there's nothing really to see here. But in your more complex application, when you try to find the bug inside the code, this can be quite helpful. Now, once you are done with debugging, if you want to run the rest of the code, then you can select resume. So resume will just continue with the rest of the code all at once instead of line by line. And let's just resume. And you can switch back to a different perspective and see the output of the application, and you can stop the server just like you stop the server here, and that will terminate our debugging session. And anytime you want to debug, just do debug as and debug on server, and anytime you want to run the code, just do run as run on the server. So one last thing, let's remove the breakpoint. Just double click on the breakpoint again, and that will remove it. So using the Eclipse debugger may be helpful when some bug is hard to find. It lets you to set breakpoints. It lets you to see the variables that you can see at that point, and it lets you to step through your code one line at a time if necessary. So this is the end of this lesson. Here's a quick summary of what we have covered in this lesson, and see you next time.